You want to take out a 172,000 loan for your mortgage. The interest rate on the loan is 4.2%, and this is over a time frame of 30 years. Your monthly payments will be $841.11, and any of our answers are going to be rounded to the nearest dollar. So we need to determine how much is still owed after making payments for 10 years. Because we are talking about loans and paying off loans, we're going to use the loan installment formula. Here is our loan installment formula right here. We have PMT, that's our payment, is equal to the principal times the APR over the number of times it's compounded a year. And then down here we have 1 minus 1 plus the APR over the number of times compounded per year, all raised to the minus NT, where T is the number of years. We're going to have to think backwards on this. So to visualize what I am about to explain to you, I created a timeline. So this is because this loan is for 30 years, I made the timeline go from the initial starting point at 0 years, and then the ending time frame would be 30 years. Now, if we imagine that we made payments for 10 years, that would be right here on the timeline. This is the 10-year mark. So for all during this time, we're making our payments, and then at that 10-year mark, we still have a lump sum of money that we owe. So what I want you to think about, just starting from scratch, this is now the amount of money that we owe, and we're going to be making payments for the next 20 years. So think of this as a brand new loan. So we have the amount of money here that we owe, and then we're making payments for 20 years. So we are going to use all the information that was given to us in the problem and solve for our principal if we're making payments for 20 years. So the principal is what we're looking for. That's our lump sum that we owe, and we're thinking about this as starting over. T is 20 years, because if we stopped at 10 years and we're looking at this as a new loan now, the amount of time that's left is the 20 years. So we're going to pay off this amount in the next 20 years. Here's our payment amount. The APR is 4.2%, but when we put it in a decimal, it's 0.042. We're doing this monthly, so N is 12. So now, when I go to plug all that information in here, I notice that the formula is not solved for P. So before I start plugging in values, I need to solve this for P. This is what we're trying to solve for. So all I'm going to do to solve for P is multiply both sides by the reciprocal of this big, messy fraction. When I do that, I get the equation is solved for P. So now I have P is equal to the payment times all of this inside the brackets here, and then divide by R over N. So this fraction here, even though it's messy, it's still a fraction, and I can multiply both sides of the equation by the reciprocal of that fraction. So the side over here clears out, and I'm just left with P. And then on the side with the payment, it's the reciprocal of this that I'm multiplying it by. So this is what I'm left with. Now, when I take all of this information and plug it in, so I put my payment in here is $841.11. That goes here. I bring everything down. My R is the 0.042. That goes here. My N is 12. That goes here. And then I have minus n times t. I have minus 12 times 20 years. Remember, we're doing 20 years because we've already done 10 years, and now we're stopping here and thinking about this as a new loan, and whatever is left over from what we've paid for the first 10 years is the amount of the new loan that we're starting from here to here. So that's 20 years. And then in the denominator, we have our rate divided by our number of times compounded per year. So that's 0.042 divided by 12. This is what it should look like when you put it in on GeoGebra to get your value. So this is our answer. Now, the question said to round to the nearest dollar. So we don't want any cents, we just want dollars. So my final answer is going to be 136,417. If it said round to the nearest cent, then I would put in $136,417 and then 44 cents, because this 7 would make the 3 bump up to a 4. So this is how much would be left at the end of the first 10 years. This is how much we would still owe if we took out this loan under these conditions.